Hello everyone, and welcome to part 2 of the Finance Project Solutions lecture. Let's go ahead and jump right back to the Jupyter Notebook where we left off last time. Okay, here I am at the Jupyter Notebook. Last time we left off, we had just created this pair plot. Notice a little bit of strange behavior on Citigroup's return, and if that stood out to you, you can then check out the Citigroup Wikipedia page, and you'll notice that in November 2008, they kind of had a crash, and we'll actually explore that a little later on. But coming up next, what we wanted to do is, using this returns data frame, figure out on what dates each bank stock had the best and worst single day returns. And you should notice that 4 of the banks share the same day for the worst drop. And did anything significant happen on that day? Let's go ahead and get started. Something we can do is just check out the returns data frame. And notice we have these columns here, the BAC return, C return, etc. If I want to get the minimum values for these returns, and they're all single day returns, I can just say .min, and it will return the single day return value minimums. Now, what we actually want are the dates when this happened. And there's a couple ways to do this. One is you can iterate through the column names. And then if you remember your NumPy, instead of calling, for example, min off of that column, you can call argmin. And argmin will return that timestamp. In this case, it's the 20th of January 2009. Now, you could do that for every single column, or Pandas also allows you to do this across the entire data frame by just calling idx min. And that returns basically a series that looks like this, with the dates or indexes of the minimum values for the returns for each bank. And you can do the same thing by saying returns idx max to get the biggest single day gains. Now, as far as the worst drops, you'll notice that a lot of them happened on the 20th of January 2009. And if you're curious what happened that day, you can go ahead and just search Google, and you'll notice that this was actually Barack Obama's inauguration date, which is kind of interesting. Something to note here, whether or not that's correlated or just a coincidence, or basically some of the market investors get panicky when some big political change happens, you can actually check out on IDX Max that, for instance, JP Morgan's biggest return date is the very next day. So don't take this as any sort of political comment or even financial advice. Stock markets can be kind of weird sometimes. Now, if we check out the next question, it says, you should have noticed that Citigroup's largest drop and biggest gain were very close to one another. So we notice that JP Morgan's gain happens the same day after the inauguration day, right after their biggest loss. But if we look at Citigroup, let me go ahead and clear that cell. If we look at Citigroup, they have 2011, 6th of May, and 2011, 9th of May as very close to each other as their worst return and their best return. And it's something significant happened at that time. Actually, yes. If you end up Googling something like Citigroup May 2011, you should get some news that looks like this, where Citigroup announces a reverse stock split. And that's essentially what happened around that time. And you can notice that it was effective on May 6, 2011, which kind of lines up with our data here. All right, so that's pretty cool. We can actually correlate or see real-life events affecting our stock prices and our data that we have in our data frame, which is kind of interesting. Now, if we continue on, what we want to do is take a look at the standard deviation of the returns, and which stock would you classify as the riskiest over the entire time period, and which would you classify as the riskiest for the year 2015. So sometimes a basic measurement of riskiness of a stock is the standard deviation of the returns of the stock. So if you have a very large standard deviation of the returns, it means your stock's going up and down a lot. Versus a small standard deviation, it means your price is pretty steady. So if you have a high standard deviation, your stock is probably pretty risky. Let's go ahead and see how we can do this. It's actually quite simple. You can just say returns, and I'm actually going to put this in this cell right here. Returns.std for standard deviation, and we get something that looks like this. Basically, the standard deviation for each stock. And it looks like the riskiest overall by quite a bit is actually Citigroup. And later on we'll see why, because it had a huge crash. And as far as for 2015, we can go ahead and say returns. And what we want to do is find out, if we take a look at the head, we want to only get values for 2015. And that's based off of the index. Meaning I want to actually grab a section or a slice of that index. And I can use that using ix, and I'll pass in from 2015 0101, so from January 1st, 2015 as a slice, all the way up to 2015 12/31 as a slice, and then call standard deviation off of that. And you'll notice that in 2015, which is way outside of the crash of Citigroup, they actually all have a very similar risk profile, with Wells Fargo being the lowest risk by not that much, and it looks like Morgan Stanley or Bank of America are the highest risk, but essentially these standard deviations are extremely close to one another. Okay, next we wanted to say create a dist plot using Seaborn of the 2015 returns for Morgan Stanley. Let's go ahead and do that. We can go ahead and say sns.distplot, and I want the 2015 returns of Morgan Stanley. I'm going to go ahead and copy this code here, and this is my 2015 returns, and then I just want Morgan Stanley, meaning I just want the MS return column. And we can go ahead and color this green just so it matches the solutions lecture. And let's go ahead and increase the bin size, or the number of bins, excuse me, since we actually have quite a bit of data. So I'm going to go ahead and say bins is equal to something like, let's just say 50. All right, and now we have a distribution of the returns for Morgan Stanley in the year 2015. All right, so here we can see as far as the MS return and the distribution, as far as what we're looking at, is that it's pretty stable. You're looking at percent returns that only deviate about 0.06 from the average. What we're going to go ahead and do now is check out a distribution plot using Seaborn of the 2008 returns for Citigroup, which was quite a volatile year for them. In order to do this, we'll go ahead and say Seaborn distplot, or sns.distplot, returns.ix, and I will go ahead and slice, go ahead and copy this, but instead of 2015, we'll go ahead and put in 2008. We'll do the same thing over here, 2008, and then we want the C return column. And let's go ahead and color this red so we can tell the difference here. And I'll go ahead and set the bins equal to, let's go ahead and say 50 again. And if I run this, if we go ahead and compare this, you'll notice that the standard deviation is actually quite a bit more stretched out, especially here, you're almost at 0.6. And if we look back for kind of a normal year for a bank, 2015, you're at 0.06. This is actually 10 times as much as far as this distribution shows the extremes out here. So this is quite an outlier. And we'll go ahead and explore what actually happened to Citigroup during this year. But this is kind of an indication here of the financial crisis that this stock went through. All right, so we're going to do some more visualizations, and a lot of this project's actually focused on visualizations. And you can feel free to use any of your preferred visualization libraries in order to recreate the plots described below. You're going to be able to do them actually with either Seaborn, Matplotlib, Plotly, and Cufflinks, or even just pandas. So you can go ahead and choose whatever methods you like. I'm going to go ahead and show you a couple ways to do each plot, and we'll actually show you how to use Plotly and Cufflinks in order to make these plots as well. Alright, so after running those imports, what we want to go ahead and do is create a line plot showing close price for each bank for the entire index of time. And there was a couple hints here to either try using a for loop or use the cross-section method to get a cross-section of the data. And here we can kind of see both methods at play. Let's go ahead and show the for loop method first. And hopefully here it's clear now seeing Citigroup as C in green, this huge crash in 2008. And that had to do with as far as their standard deviation being quite large for that year. But anyways, let's go ahead and go back to the for loop. I'm going to go ahead and say for tick in tickers, which remember is that list of stock tickers, call bank stocks tick closing price, and then just go ahead and plot this out. And I'm going to plot this out. I'm going to specify that the label is equal to tick. That way we know what line is which as far as colors go. And then I'm also going to specify fig size to be stretched out a bit, just so we can kind of get this same visualization we have here. And then finally I'll call pt2.legend so we can see the legend. And if I run that, I get the same plot. It looks something like this. So we can clearly see that Citigroup just really crashed after 2008, the Great Recession. And what's interesting as well is this Goldman Sachs red line, which kind of like dips and then bounces back up quite quickly after the recession. And you have to zoom in further on to see the other banks and see how they performed. But relatively speaking, it wasn't nearly as much the same effect as the other stocks. Let's go ahead and show you how to do this with cross-section. Could have also said bank stocks.xs with key equal to close. Axis is equal to 1 since we're looking at the columns. Say the level is stock info. And if we just take a look at that, this is basically all the closing prices for the stocks. And then what we have to do there is just call plot, and you get the same plot. So instead of doing a for loop, you can just do this all in one line using a cross section. And again, you can change the figure size and do any other matplotlib commands you want on that plot. Finally, let's go ahead and show the plotly way to do this, which is essentially just this same line, which creates the data frame, but then you call iplot off of it. And cufflinks will now allow you to create this very nice looking plot where you can visualize things and actually see the values and kind of play around with it. So if you actually want to kind of zoom in on the non-Citigroup or Goldman Sachs stocks, you can go ahead and do that by just grabbing a cross section and then checking out the dip. So you can see the dip here during the financial crisis, as well as some weird behavior during things like stock splits, such as this one in May. All right, so this makes it a lot of fun to play around with the data and kind of explore the stock prices during the financial crisis. What we're going to go ahead and do is move along to moving averages. And we're going to analyze the moving averages for these stocks during the year 2008. So the first thing we need to do is plot the rolling 30-day average against the closing price for Bank of America stock for the year 2008. Let's go ahead and show how we can do this. I'm going to say BAC and check out the head of BAC. Remember, that was my very first original data frame for Bank of America before we actually put it into bank_stocks. And then I'm going to grab the close column off of that, and I'm going to use the IX method to go ahead and slice the dates I want. And I want 2008, January 1st, all the way to 2009, January 1st. So a whole year. And then what we want to do is use the rolling method. So Pandas has the ability to give you a rolling method for a moving average. And then we can say mean as our method, and then we can just go ahead and plot this. And we can actually plot this with a label so we can show what we're looking at. So we'll go ahead and say label, this is a 30-day moving average as our label. And the next thing we're going to do is we're just going to plot the same thing, BAC close, but in this case we'll plot it against the stock price. So we'll say dot plot, and this label will be BAC close. And then we'll call plt.legend. So if we just run that, we get a plot that looks like this. And we can go ahead and stretch this out if we wanted to by saying plt figure, fig size, and we can state this to be something a little nicer like 12 by 4 to kind of stretch it out. And there is your 30-day moving average against the actual closing price. And this allows you to kind of see the general trend of the stock as it goes along. And you can change this window to be the weekly moving average or 60-day moving average, whatever you want. All right, the next thing we wanted to do was to create a heat map of the correlation between these stocks' closing prices. Let's go ahead and show you how we can do that. We can call sns.heatmap, And now we want to get a correlation of the stock's closing price. Let's go ahead and just hashtag that out and actually build out that data frame first. It's going to be very similar to what we've been doing before. We'll go ahead and grab the cross section of the closing prices by saying key close on axis equals 1. The level is stock info. And if we just check that out, that's this, just the closing prices for the stocks. And if I say CORR, that gives me the correlation. And now I have something in a matrix form that I can call into heat map. So I'm going to go ahead and unhashtag out, close that, and say heat map here, and check out my heat map. And now I have my heat map, and if I want the actual annotations, I can just say annot equals true, and that will go ahead and put in the annotations here. And here we can see the correlation between the closing prices of the stocks. And something we can optionally do as well is use cluster map to actually cluster these correlations together. Maybe hopefully make it a little more clear as to what's going on. So instead of heat map, all you have to do is type in cluster map, and you run this, and you should get a plot that looks something like this. So it looks like Seaborn tried to group together Citigroup, Morgan Stanley, and Bank of America, and their correlation together into kind of one group, as well as Goldman Sachs, JP Morgan, and Wells Fargo kind of into another group as having some sort of correlation to each other. All right, and you can kind of check out which plot or which stocks are the most correlated with each other. It looks like it's JP Morgan and Wells Fargo, as well as Morgan Stanley and Bank of America. Okay, so that was it for the financial project. There's a part 2 optional that we'll show in part 3 of the solutions lecture, and that has more to do with iPlot and some of the special capabilities of cufflinks. But due to its heavy reliance on cufflinks, it's kind of an optional thing that you can kind of explore on your own in case some of that functionality is broken in the future. But I hope you enjoyed this project. It was meant to be extremely challenging and difficult, but that's kind of by nature of stock and financial analysis, the kind of thing you'll encounter if this is something you're interested in. So a lot of these things are quite tricky and hard, but hopefully you can see that once you feel really comfortable with pandas and Seaborn, a lot of these things become a lot easier than if you had to do them, for instance, in Excel or in another programming language. For a lot of these answers with just a few lines of code or even just one line of code. And what's really cool is the fact that you can make something like this in one line of code. So you can definitely impress your colleagues or your friends by showing them your own financial project analysis. Okay, hope you enjoyed the project. Coming up in part 3, we'll just go over the optional section of these solutions. Thanks everyone, and I'll see you at the next lecture.